Okay, so on this example, we've got the diameter of a spherical ball bearing was measured to be 7.2 millimeters with a possible error of 0.1 millimeters. State answers exactly over 7 decimals. Use differentials, that's kind of a key word there. Use differentials to estimate the maximum error in the calculated volume. Okay, so we got to have the volume of a sphere formula. So the volume sphere is up, a big ball, like you see here in the image, a ball bearing. Volume of a sphere formula. You can put this in your notes for the exam. 4/3 pi r cubed. Makes sense. It's third power because volume is three-dimensional. Okay, so what are we going to do then? So what we're going to do is take the derivative. So this is v. We're going to take dv dr. The derivative with respect to the radius. What's going to happen? That 3 is going to come down, and so it's going to be 4/3 times 3 pi r, subtract 1 from it, squared times, or no, that's it. There we go. dr, but that's obviously not going to do anything. These guys cancel. So then multiply both sides by dr. Boom, boom. We get dv. Try that again. dv is 4 pi r squared dr. So remember what d means. Let's be clear on this. This means difference in volume. And this means d stands for difference, right? Difference in radius. So there it is. That's differentials, right? Differentials means derivative. We did it. Okay, so now what are we going to do with that? Well, um, it tells us up here that the diameter was 7.2 and with possible error 0.1. Okay. So the diameter, remember the diameter is like all the way across the ball, right? So the diameter goes like from this side here, let me try to do a good job, all the way across to that side. So that would be diameter. Diameter goes all the way across. Okay, it looks like I did that a little high up, huh? Yeah, I don't like how I did that. Maybe I'm being too picky. Who cares, really? We'll just do it here. There to there. There we go. So that's diameter. It's all the way across. And so radius is half of that, right? Radius is halfway across. So basically, says up here, diameter is 7.2, and that's equal to twice the radius. So radius is going to be half. I'll just come down. So radius equals 7.2 divided by 2, which is it's going to be 3.6. We get the radius 3.6. So okay, but also an important fact. It says that possible error 0.1, that means DD is 0.1. DD stands a difference in diameter, right? In other words, what this is, they're trying to measure the volume of a ball bearing. They measured the whole diameter. They got 7.2, but they know there could be an error of up to 0.1. That means there could be a difference in the diameter of 0.1. Well, the radius equals, I kind of run out of room here. Let me bring that all down here. So DD, difference in diameter, 0.1, that's difference in diameter, like dr, dv. So dd, I mean, because of the air, right? The air, really, the diameter could be different by 0.1. There's a possible error, right? So whatever tool they're using, this is real life engineering, things like that. They measure things. Nothing's exact. There's tools that have a certain amount of accuracy. So if they know that there's a possible error of zero point 0.1 in the measure of their diameter, then the diameter could be different by up to zero point 0.1. What does that mean about the radius? Well, we know the radius is equal to half the diameter, right? So that means that the dr, the difference in radius, is going to be half the difference in diameter. So it's going to be half of zero point 0.1. So therefore, I guess I'm running out of room. Keep thinking I don't need a whole nother sheet, but I guess I'll do it. So then dr equals, what's that going to be? 0.05, right? That's a difference in radius. It's half the difference in diameter because radius is half diameter. Radius is half diameter. Radius is halfway across. Diameter is all the way across. So the difference in radius is going to be half the difference in diameter. Half of zero point 0.1 is going to be that. The dr is that. And I've got the r up here. The radius is 3.6. All right, we're ready to plug them on in. So that means dv equals 4 pi r. Here's the r, 3.6. And just bring that on down. Plug that r in there. And then the dr, 0.05 right here. Plug that in there for the dr, and then hit the buttons on the calculator, the dv, which is the air in volume, right? The difference in volume due to that air amount. So now we go to Desmos, 4 pi, 3.6 squared, 0.05. Let's go there. 4 pi, 3.06. Is that right? Am I doing that right? 4 pi, 3.6 squared, 0.05, 3.6 squared, 0.05. Oops. And 0.05. I'm getting 8.14300. 8.14300. 8, and there it is. 8.14300. So that's how we find the possible difference in volumes.